Presentation like logic, audio signal processing, DSP are normally handled by us. They rely on DSP for signal enhancement, for clearer and sharper, powerful. DSP algorithms also add unique sonic characteristics like warmth or brightness. At the lowest hardware level, logic gates provide the basic control and processing capability for managing these audio digital signals. Representation and transformation analog to digital conversion. Audio starts in analog form, a continuous sound wave. To process it digitally, it must convert it using sampling, taking measurements at regular intervals and quantizations. Representation after conversion, audio signals are accessed as discrete values, individual numbers instead of continuous weight. It's an easier way using sequences of zeros and ones because digital systems process binary data. This could mean amplifying certain frequencies, reducing noise, or adding effects, all by modifying those digital numbers. It's the building blocks of DSP. AND gate. Outputs high only if all inputs are high. OR gate. Outputs high if at least one input is high. NOT gate inverts the input signals. NOR gate. Outputs high only if all inputs are low, as you know. Inverter, if input is zero, the outputs combine to create more complex digital audio processing function. The building blocks of DSP has a more fundamental logic in digital systems. Let us understand it in a more conventional way. AND gates outputs are high signal only when all its inputs are high. If any input is zero, the output is zero. OR gate inputs are high signal, at least one input is zero or high. NOT gate inverts the input signal. NOR gate outputs high only if all inputs are low. Implementing basic DSP operations with logic gate signal addition in digital systems. Adding two signals is done using XOR gate along with carry loop adders. This allows the system to add binary numbers representing audio signals quickly. Signal multiplication. This can be done by repeatedly adding one number to itself and shifting it based on binary multiplication rules. Logic gates can manage this addition and shifting. Delay elements using flip-flops, especially circuits made from logic gates. We can create delay in the signal. This is useful for effects like echo or reverb where sound needs to be repeated after a short. Logic gates based audio filtering. Filter design a low pass filter allows low frequencies to pass while blocking higher ones. We first decide the cutoff frequency, meaning at what point higher frequency should be removed properly. We can allow only desired frequencies to pass through. Testing. Once the filter is built, we test it to check frequency response, how well it blocks or allows the different frequencies. Operation threshold detection. Logic gates are used to monitor the audio signal levels and detect when it crosses a predefined threshold. If the audio gets too loud, the system detects it instantly. Gain reduction. Once in a peak is detected, the circuit triggers gain reduction, lowering the volume of that part of the system or signal. To avoid distortion, output after applying gain reduction, the possessed output or audio is sent out. This compressed signal has fewer extreme volume changes, making it clear and more balanced. Since the operations are the hardware. Advantages: reliability, high predictability, direct hard control. Limitations: complexity for advanced algorithms, limited precision, scalability issues. Future trends, logic gates in advanced audio processing, integrations or filled programmable gate arrays are devices that allows flexible arrangement of logic gates. They can be programmed to handle custom DSP tasks that can be changed later without new hardware. Custom hardware. This involves designing specialized processors or circuit dedicated to specific audio effects, offering better performance than general purpose systems. Hybrid approaches, combining hardware DSP using gates with software DSP on computer or processors. This provides both flexibility and speed in processors. This provides both flexibility, speed, complex audio signals in processors, which is easy for the processors to process the data. Vision theory, practical application keys, takeaways, logic gates from the core of digital audio processing. They offer basic control over how digital audio signals are processed. This helps in hardware design and a better understanding of digital signals processing techniques. Creating more simple audio based hardware, designing custom audios, processing hardware quickly, gaining based audio systems, real time, flexible processing, designing new hardware for spatial audio effects, exploring hybrid solutions that combine hardware and software DSP. Digital audio and aesthetic exploration. Welcome to the world of digital audio signals. This presentation highlights the visual and auditory beauty behind some sound technology. As we see in the above slides, the logic gates, NOR gates, XOR gates has provided us the informative and very helpful data through this, and this is the digital audio that explores the system of the logic gates, NOR gates and XOR gates as following as it explores in the other slides also. The essence of sound, analog versus digital. Now in audio systems there is no or minimum use of logic gates, NOR gates or XOR gates. Analog sound continuous waveforms like grooves on vinyl record. Analog sound is like and continue waveforms that grooves like on a vinyl record. Digital sound discrete samples forming a stepped approximation as in CDs and MP3s. Digital sound is used in a discrete samples like forming a stepped approximation as in CDs or MP3s like we used in laptops and all sound systems. This is like that only. The key difference is continuous versus discrete representation waves. As this shows, this is a basic and need help for the people who do always like musics and essence of sound, analog, digital, create samples for stepped approximation as in CDs and MP3s. This all are useful data for that. Sampling capturing the sonic landscape. Requires the Shannon theorem. This theorem is not relatable or not used in any other slides before. This is not that common theorem. It's a rare theorem explaining only rare components and features about it. It's not like needable theorem, but still its uses are sampling frequencies must be more than twice the highest audio frequencies. Its uses like the frequencies we sample or the musicians or the need who needs it, who samples it, must be more than twice the highest audio frequency. Common rates are for 44.1 kilohertz standard CD quality. Common rates like we purchase a standard CD quality that's common that is called common rates, and that common rates hertz is 44.1 kilohertz only. We can purchase also high quality kilohertz like professional audio use for 48 kilohertz that are used by professionals who perform daily tasks, daily necessities. They used to perform it, the daily data transfers, daily use of logic gates and professional audio use. They can use it 45 kilohertz. Audio interfaces connecting walls converters, ADC analog to digital conversion, DAC digital to analog conversion, latency and I/O low latency essentials for recording inputs like XLR, USB and MIDI converters latency and I/O. These are the interfaces connecting walls. Aesthetic design in audio systems. As you know, nowadays people prefer aesthetic designs because it's like minimalist and in calm tones that attracts people more for working there and create more interest in their working area. Equipment design combines functionality with visual appeal. UI in DAOs, intuitive controls enhance creative flow. Psychology of design, sounds and visual shape user experience. Iconic brands merge technology with art to inspire you. Digital signal processing DSP, clutching sound, equalization, adjusts frequency balance for clarity and tone, reduces dynamic range for consistent volume, reverb and efficiency, simulates bass and with chorus flawless. Digital signals definition. Discrete time signals with quantized amplitude levels, binary presentation expressed as zeros and ones for bits, compared to DSP, digital analog converter DAC. These are the components that are used for digital signal system for a person who needs it daily in daily purpose. Video theoretical application key takeaways from the core the digital processing. High resolution audios, greater detail and clarity beyond CD qualities, interactive audio, adaptive sound experiences with user input. Technology evolution, new tools deepen connection to sound and